All right. So, guys, the questions that we're going to cover today, first of all, I'm going to share with you people the list of the questions, right? So, let's see the agenda first of all. Right. So, let's see that particular list. And you people just tell me one thing, if the screen is visible or not, right? So, is this list visible to you people?
Yes, ma'am.
Yes. All right. So this is going to be list, and you people just tell. This complete tutorial is going to be on live on YouTube as well. So you people can access this afterwards also if you want from YouTube, right? So I'm going to start with the session now. So basically, very simple. So there are lots of topics that we are going to cover in subsequent sections, but today we are going to start from a very simpler one, which is static sliding window, right? So first thing comes first, which is that what is this sliding window and where do we use this particular concept, right? So we're going to start with this particular problem statement, which states that given an array of integers, right? So first of all, let us pick this question and then we will try to understand this question, right? So this is our question and we are going to change the color of this text because this is going to be the base question for us from where we will try to understand that what is this basically this static window, right? So we want to understand that concept from here. So now what happens is that suppose this is our array, right? So let us first of all draw this simple array and this is our white ink and this is our array. So suppose let us consider that in this particular array we are going to have suppose four elements, right? And each of these elements, let's have five elements and each of these elements is suppose of 4 bytes, right? So how big are these elements? So each of these elements are 4 bytes long because integer type array is there. So int arr is equals to this array, right? So you know that in array, you basically point out each of the elements with the help of index. So this is your index number 0, then index number 1, 2, 3, and 4, right? So what happens is that when we talk about sliding window, we just consider a single window, right? Whose size is fixed. That's why this is a concept of a static sliding window, right? So basically, we are all the problems of sliding window, we are dividing them into two parts. So the first part is a static window and the other part is dynamic window, right? So the naming convention of the sliding window is based on this fact only that if this window, which is basically traveling on your array, right? If it is fixed in size, then this will be called as a static window. And if this window size can change, then this will be called as a dynamic window. So in today's session, we are going to cover only the static sliding windows concepts and questions, right? It means that suppose let's consider that we have this array and in this particular array, we have to find out whatever the maximum sum is there, right? So first thing comes first, which is, so suppose this is our array and in this particular array, we have several elements. So 2 is there, then 3 is there, then 8 is there, then 9, 6, 4, and then 1. So suppose these are our elements, and now what we have to do is we have to see that if k is equals to 2, k is basically the size of your window. So we are saying that this is a static window concept. So k is equals to 2 means that a window of size 2 will appear over here. Now, what is being said is that this window can slide over this array. So that's why the name is sliding window, that this window of fixed size can slide over the array. So we'll start from here. So we are saying that first of all, this window of size 2, right? This window means this block of size 2 is containing 2 and 3 as its element. If I'll ask you that what all elements are there in the window right now. So you people will simply say that the elements right now in the window are 2, comma 3, which is absolutely correct. Then I'll move this window slightly, right? So I'll say that let's move the window by one step. And as soon as I'll move it by one step, now what all elements are there in the window? So you'll say that 3 and 8, these two elements are in the window. Then again, we are going to move this window ahead and we are saying now what all elements are there. So you'll say that 8 and 9 are there, right? Again, you want to move the window. So again, we are moving the window and this time 9 and 6 are there in the window, right? Again, we want to move this window. So again, we are moving and 6 and 4, these two elements are there in the window. Again, we want to move the window and this is going to be the end. So as soon as we reaches the end, our window basically is going to stop, right? That is, this is it. These all windows were possible. So if somebody would ask us that how many windows were possible, so you will say 1, 2, 3, 4, 5, 6. 6 windows were possible if the size of window was 2. Is it clear, everyone? Does this make sense? That if size of window was 2, then there were 6 total windows possible, isn't it? Right. So now what happens is that the size of window can also change. What it means is that if suppose somebody would say that the size of K is equals to 3, it will simply mean that now instead of having 2 as the size, now this window is going to be of size 3. So it simply means that this window which was of size 2 now is of size 3. So it will cover 3 elements at a time. So this is the meaning of k equals to 3, right? If now you want to move this window ahead, so in first window, we have these 3 elements that are 2, 3, and 8. If we'll slide this window a little bit ahead, then the elements that are there in the window are 3, 8, 9. If you will slide further, then 8, 9, 6. If you will even slide further, then 9, 6, and 4. If you'll go even further, then 6, 4, and 1, and this is the last window, right? So this is the concept of static sliding window. Now, what happens in dynamic sliding window is that if suppose you're starting with the first location and if suppose your window is of size 1, then based on certain circumstances or based on certain conditions, your size of window can also change. What it means is that in the next, in the next iteration, the size of window can become 2. In the next iteration, the size of window can become 3. It can extend from the right hand side and it can decrease the size of the window from left hand side as well. So the window can move from left and right both sides and it can increase and decrease its size. And this is the concept of dynamic size sliding window, right? So that is our second type of window, which is dynamic size, right? Dynamic sized sliding window. Make sense? So these are the two concepts that we're using here: static size sliding window and dynamic sized sliding window, right? So this is basically about the overall concept of these windows. Now we want to learn about the time complexity that the algorithms uses, right? And also we want to learn about that what all different problems can come from it. So we're going to start from a easy section and later on, subsequently, we're going to move towards the harder part of this whole thing, right? So are we good to go here? Like, are we completely understanding these concepts? Like, these are very simple, isn't it?
Yes, ma'am.
So now let us move to the next part. Now what happens is that this first question is there. So let's try to cover this one. So let's just start with this question. So this question is saying that suppose you are given an array of integers, find the maximum sum of any contiguous subarray, right? So contiguous subarray means only that you're talking about something contiguous, right? Subarray means that at all the elements that we're considering are neighboring elements, right? This is the meaning of contiguous subarray. So now let us try with some questions here. So let's decrease the size of this pen to 3. And now I'm saying that suppose this array is there and we have to find the maximum sum of any contiguous sub-array of size equals to 3. So we are basically now going for k equals to 3, that is size 3 window. All right. So we started like putting some elements in the array. So the starting element is 2, then 4 is there, then 6, then 8, then again maybe 12 is there, then 1 is there, then 4, then 3. So these are like our elements, and because the size of k is 3, it means that the this is basically a static sized window question. So in the very beginning, we are going to have a window of size 3. So let's just start with this one. So this is our first window. So the very first thing that we are going to do is we are going to compute the sum of our first window. Now, because this first window is basically the very starting point, so we calculated the sum of the first window because we have to calculate the maximum sum that is possible. So we are saying that, okay, what is the sum here? So the answer would be that the sum is 2 plus 4 plus 6, which is equals to 12. Right? So the sum of current window is 12. So we'll have a maximum variable, and inside the maximum variable, we'll simply say that, okay, let us keep 12 as our first alternative, and let us see that what maximum value could be there inside all the windows that are going to come, right? Then the next step would be to move this particular window. As we are moving this window, we can see that we are leaving this 2 out and we are adding this 8 inside the window. So the same procedure we are going to apply on the sum as well. So in that second window, if you want to compute the sum, there are two ways. Either you can start a loop and you can say that 4 plus 6 plus 8, but we thought of this, that this is basically doing some extra computation. Let us do one thing, that instead of doing this sum altogether again, we can simply say that inside this 12, you can add this 8 because 8 is the incoming number and the outgoing number was 2. So we can subtract it from here. And the final sum that we're going to get here is 12 plus 6, which is 18. Right? So this is 18. And now we are going to compare this with 12, and obviously 18 is greater. So we'll update our max as well. Now again, we will move our window a little bit. And this time, when we are moving this window, then 4 is going out of the window. So in the third window, 18 minus 4 because it is going out, and 12 is coming inside. So plus 12. And the final sum here would be equals to 18 minus 4, that is 14. 14 plus 12 would be 26. And again, 26 is a bigger number. So we're going to update this max value as 26. Right, so this is how we're going to move throughout our array, and we want to find out that what is that maximum sum which is possible here. Does it make sense that how we are doing this process? Right, we're going to move forward. Right, so now the element that will be removed from this window will be 6, and the element which is added here is 1. So the last sum, that was 26, we have to subtract 6 from it and we have to add into it. So the final sum would be 21, but a bigger number already exists. So we are not going to update that maximum value. Now we are going for the next window. So we are going to move this window even further. So now we are saying that, okay, what are the next elements that are there? So you'll say that now you have to remove this 8 in the next window. So this is our window number 5. And inside window number 5, our sum is 21, from which we are subtracting 8 and we are adding 4. So in overall, the answer is coming out as 17, and 26 is basically bigger than 17. So we are not going to update this 26. And the last window is when we are reaching this end. And at this particular point, what you're doing is in the sixth window, whatever sum you are having, you are adding 3 to it and you're subtracting the outgoing number, which is 12. So the final number would be 17 plus 9, which is 17 plus 9, which is 26. And 26 is basically, and 26 is basically already existing here in the maximum. So the final answer which we have to produce is the maximum sum, which is 26 in this particular case. Does it make sense, everyone? That how we have slided the window, right? How we
Yes,
are
ma'am.
sliding the window, and then how we are getting the maximum sum out of it, right? So this is the very basic concept of sliding window, static sliding window, right? We're moving the window one by one. We are getting the sum. And how are we getting the sum? So we are simply checking that whatever the current sum was there, you have to subtract the outgoing number and you have to add the incoming number. So that's how you do it, right? So very simple thing, right? Now we want to go for applying it into the algorithmic way into the program. But let's take a simple one more example so that this will make more sense, right? So suppose the size of window is 4. Let's suppose the size of window is 4. So whatever sum x is there, because now the size of k could be 4 also, it could be 100 also, right? So how does it impact or how does it give us a better solution? We have to look for that as well. So just consider this example that suppose here we have these numbers, which is 1 is there, 4 is there, 3, 2, 6, 8, right? So suppose these numbers are there. So now we have to consider that what was the brute force approach and how is this particular approach that we have just discussed using sliding window is better. So we want to know about this. So let's see. So suppose this is our current array, and in this array we are saying that the size of window is 4. Right. So right now we are saying that the value of k is 4. In the brute force approach, what you have done is, in the brute force approach, we have to basically calculate each time that what is the sum of this particular window. So how many windows are possible if the value of k equals to 4? So you will say that this is our first window, then we'll move this window by one position. So this is our second window and this is our third window. So there are 3 windows possible, right? So we'll say that total number of windows that are possible are n minus k. So let us see to it that what is the actual formula that will come out. So 1, 2, 3, 4, 5, 6. So 6 elements are there and total number of windows are coming out to be 3 and the value of k is 4. So 6 minus 4 plus 1. So this is the formula by which you can get the value of number of windows, right? So these are number of windows and in each of the window, you're going to go for a simple iteration where you are going to do the addition of each of the numbers. So total time that will be taken here is n minus k plus 1 into k, right? Into k because you have to use a for loop in which you are going to do the addition of each of the numbers 1 plus 4 plus 3 plus 2, right? So this is like the brute force approach. Whereas if you'll go for this approach, this sliding window approach, right? In this particular sliding window approach, if you want to see that what will be the time taken here, so this time you're going to like run this first window, you have to compute obviously. So the in computing the sum for the first window, you're going to take k times, right? Afterwards, whenever you will slide the window, it will be one more computation because you're going to add a single number and you're going to subtract a single number. So in the second window, only one computation will be needed. In the next window, because total windows are going to be 3. So in the next window also, there is only one computation that is required. So total number of computation that are coming here are 4 plus 1 that is equals to 6, which is also equals to n. So now you have to compare that which particular algorithm do you want to use. Do you want to use something which is working in n minus k plus 1 into k time, or do you want to use something which is giving your answers in n time? So obviously the worst case of n is much better, right? So that's why you want to go for this sliding window approach. Does it make sense? Here we have compared both of the algorithms, right?
Ma'am, please repeat the second one.
What I'm saying is that suppose we want to go for this second approach, that is sliding window approach. This first one is clear, isn't it? That how this n minus k plus 1 into k is coming,
Yes, ma'am.
right? So here we were simply saying that there are n minus k plus 1 windows, and then in each of the window you have to basically compute something like this, that is 1 plus 4 plus 3 plus 2. So this will be for the first window. Then in the second window again it will be running for 4 times because this time you will be computing 4 plus 3 plus 2 plus 6. This is brute force approach. And then in the last window, when your window will be this one, then you will be doing something like 3 plus 2 plus 6 plus 8. So each time four computations are needed in each of the window. That's why this formula is coming. That is n minus k plus 1, that are number of windows. And into k because each time you have to do k computations because you are adding k numbers. Right. In sliding window technique, we are saying So let us just rub it off and we'll keep the final answer here in the brute force approach. So we are saying that how much time was it taking? So n minus k plus 1 into k, right? So this was the final output that was coming. So this was the worst case time complexity. Now we want to go for sliding window. So in sliding window, we are saying that whenever you are trying to compute the very first window, so in the first window, right, in the first window, whatever the size of your k is, that is, whatever the size of your k means window is, that many computations you surely need because you have to compute this one 1 plus 4 plus 3 plus 2. But later on in the second window, you will simply say that whatever this sum is, so suppose this sum is x, so we have to do a single computation which is x minus 1 and plus 6, right? So this is a single computation. Here we were doing 4 computations because the size of window could be anything. So right now you can say that this is also done in a single line, but you have to use a loop, right? So you have to use a loop here because the value of k could be anything. It could be 10, it could be 100. So you have to go for k times iterations and you have to do the sum. But later on from the second window itself, you need only one computation. In the second window, you simply have to remove the first item that you're leaving and you have to add the next item which you are basically going to contain this time. So a simple single computation is required. In the third window, which is our last window, in the third window also some y answer is there. So from this y, you have to you have to remove this element which is leaving us, which is 4, and you have to include this element which is the new element which is 8. So that's how we are going to go for this sliding window concept. So these many computations are required. So 4 times it is running in the first window because first window you have to compute all of the elements you have to compute with the help of a loop. But later on, single computations are required. So that's why we are saying that plus 2 more computations are required. So if we do the addition, it is coming out to be 4 plus 2, which is equals to 6. And 6 is basically the value of n as well, because total number of elements are 6. So it simply means that sliding window is giving us the answer in n time, whereas brute force approach was giving us the answer in n minus k plus 1 into k time. So that's why we are choosing this sliding window concept for this particular question. Does it make sense now?
Yes,
Ma'am,
ma'am.
thank you.
All right. Now let us go further. Like now we want to basically go for its implementation as well. And it is going to help us a lot. So let us see both of the approaches. And later on, we are going to see the questions as well. So here, this is our first implementation. Let us go for it. All right. So let's make this particular file. Let's name it as, what do we have to name it as? We have to name it as maximum sum. Okay. So this is our very first maximum sum program, right? In this program, so first of all, let us create a class, and you people can also do it side by side as I am doing it here. You people can also try it on your systems, right? Because that's how we learn a lot of things by doing. So practicals are like foremost required. You have to be very much practical in your approaches, right? And I think that the font is also visible. And yes. So now what we have to do is that first of all, let us take one array and I'm going to initialize this array to 2, 5, 1, 8, 9, 5, 6, 7, 4, 1. Right, so suppose this is our array, and this time because we are right now working on a static window, so I'm saying that the value of k is equals to 4 and we have to get the maximum value. So the brute force approach would be that we will have this maximum and we'll say that let's suppose we have initialized it with some integer min value, right? Because obviously we are going to have some maximum value afterwards. So this is how we try to find out maximum in a simple array as well. So that simple thing we are doing here as well. Now, what we are saying is that let's just start with the calculation of the first window. So you people know, let's go for the brute force approach first of all. So brute force says that you have to calculate each time that what is the sum, right? So we are saying that, okay, we are going to do that. How many times or how many windows are going to be there? So we have already calculated that the number of windows, that are there are equals to n minus k plus 1. Right? So we're going to put that same formula over here as well. That is, we are starting the iteration from 0 and then I is less than n means arr dot length. So array dot length minus 1, sorry, minus k. So k value is 4 plus 1. So this is going to be our total number of windows. We are starting from 0. That's why I less than we are keeping here, and afterwards I plus plus. So these are like our number of windows, and then we have to compute the sum each time. So int sum is equals to 0, and then you have to run this internal loop for k times because the size of window is k. So int j equals to 0, then j less than k, and then j plus plus. So this is our basically the window calculation we want to do here. And now we are saying that, okay, sum is equals to sum plus ARR I plus J, right? So with the help of this, basically I is giving us the very first element of the window. So we are each and every time what we are going to do is that if suppose the window is starting from 0, so we are saying that the first element of this window is going to be 0 plus 0, that is 0th element. Then the second element would be 0 plus 1. Then the third element would be 0 plus 2. Then the fourth element would be 0 plus 3. In the similar way, when the window initial point will change, right? That is, if suppose now we are moving the window and this time the window is starting from 1, so each of these elements will start from 1, and that's how we are moving the window one by one. We are sliding the window like this, right? So with the help of J, this is what we are basically giving the offset, right? So you people must be thinking that why are we going so much in detail? And the reason is that if our base is strong, then we'll be able to move on our when we'll move towards our advanced level questions, it will be very smooth journey for us. So that's why we want to make every concept very clear, because I don't know that which particular concept is clear to us and which is not, right? So that's why we are moving each time, like whichever algorithm we are covering, I will try to not move very fast. So that's why we want to keep our sessions daily, right? So that we can have our pace, have some patience, and we can cover all the algorithms very well, right? So that was the agenda for having the classes regularly. Does it make sense? Why we have jumped from Saturday, Sunday to the regular classes? This is the main reason. Is it clear, guys? Right. So we understood this, that okay, this is providing us the offset and we are calculating the sum. And just after calculating the sum, we will simply go for that. If suppose maximum is smaller than the sum, then you have to uh, basically reassign the sum value to the maximum. And at the end, you have to print this particular maximum value. So this is our brute force approach, and if you'll run it, then you'll find the answer. So whatever the maximum value, I think that this one is going to be the maximum value, which is 28. All right. Now the second approach was our sliding window approach. But before that, we do understand that what this particular thing is doing, right? So basically this loop that is at line number 10 is for the number of windows. And afterwards, this internal loop is for the offset. That is, we want to travel the element of that particular window. So this internal loop is for traversing those windows that are going to come here. Does it make sense that how this time complexity of n minus k plus 1 into k is coming?
Yes, ma'am.
Online, guys? So I think that
Yes,
it is
ma'am.
clear, right? So now let us move to the next approach, which is the brute force is done, but this time we want to go for another approach, which is our sliding window technique. And this is sliding window. And in this sliding window technique, we were saying that you have to calculate the first window sum. You have to calculate that particular sum, and afterwards you have to go for sliding the window, right, manually. So let's just start with that. So we are saying that initially let's compute our first window sum. So first window sum we are calculating. First window sum we are calculating. And the first window sum, how do we calculate? So int I is equals to 0, I less than k, I plus plus. So this is our first window. And here we are saying that suppose some maximum is there, which is initial, some sum is there, which is initialized with 0. So this is our first window. We'll simply say that sum is equals to sum plus, right? Sum plus ARR I. Right, and we did this calculation before as well, and we were saying that yes, for calculating our first window, we need to run a loop for k times. So that is why the time complexity for this one will be k. That is absolutely correct. And then we have to run our window for two more times, or in this particular case, it will be even further. So basically, the number of windows that could be there, so that many number of times you have to run your uh, single loop. So this loop is coming out, and this is saying that I'm going to start from I equals to. So now we are going to start from the element which is going to be which is going to be included, right? So what we are saying is that this particular second loop, it is going to start from this particular place. I'll show you. So this window we have already calculated. So now I'm saying that let's start our I value from this point, right? If you start it from this point, then it's simply saying that include this 6 and then whatever this index is. So suppose if this index is x, so x minus 4 will give me this particular index, which I'll simply remove from it. And till what point I have to go, like I have to increase the value of this x. So I have to do it until I'm not reaching this end point, right? So here I'm saying that let's just start this I value from k, right? So if the size of k is 4, then we are starting this particular element, or this particular window. The end point of this window is going to be k, right? The next element to be included is going to be k. So that's why we are going to start from I equals to k, and then I should be less than this ARR dot length, because we have to go till the end, right? And then I plus plus. So this I is basically referring to us the next element to be added, right? So this I is equals to next element to be added into the window, right? So this is basically the thing. And afterwards, we are saying that sum is equals to, now the new sum will be equals to the previous sum. And in that particular sum, you have to add this new value, which is ARRI, and you have to subtract ARRI minus K, right? So each time a new computation will be done. And after every computation, you have to check it with the maximum. So this time we have basically said that maximum is equals to sum. It is basically equals to the first window sum. And if later on, if it changes, that is, if maximum is smaller than the sum, then we'll update it. So we'll simply say that max equals to sum. So now this time it is working, this algorithm is working for n times. And if we'll just print the sum, so whatever final maximum value is there, you can get it printed. And let us see the answer here. So let's run it. And again, 28 is coming out as our answer, because the output is going to be same, right? So this is how this algorithm works. Does it make sense? This particular algorithm. This is our first window, and after computing our first window, we are simply sliding our windows, and we are doing this particular computation, right? If there is any doubt, you people can ask. Otherwise, we'll move to the next question. Is there anything that you people want to ask about? That how
No,
to
ma'am.
compute this? No? All right, let's just start with some problems then, right? So we have these many problems that we have to cover today. समझ में नहीं आया, क्या नहीं समझ में आया, Ketan? Let's see. So see, let's take a very simple example to make it. easy for you people. So let's take the value of k equals to 3, and this is basically a, let's take a running example basically. So if this is our algorithm, then how is it working? Let's see it in a running example of it. So let's change the color to white, and I'm just deleting the comments, right? All right. So now see what it is saying is that suppose you're having an array, and in this particular array, you are having these elements, which are 2, comma 5, comma 1, 8, 9, and 5. And initially, we're going to have some window of size k equals to 3. So what I'm saying is that first window you have to compute uh, first, and afterwards you can go for just sliding, simple sliding. So initially we are taking sum is equals to 0, and this particular loop is working for k times, which means that it is going to work for 3 times. So 3 times means that it is going to add 0, 1, and 2, these 3 elements. So this loop is working for 3 times, and it is adding these 3 values, 2 plus 5 plus 1, which is basically 8, right? So this sum is basically 8 right now. And we also have to take a maximum value. So we have updated the maximum to 8. So this is these particular lines. This is what they're doing. Afterwards, what I'm saying is that you have to start from the next element. So now the I variable is pointing to this 8, right? This pointer is pointing to 8. So what it is doing is it is basically moving this sliding window to this particular point. The end point is denoted by this I value, right? So if I is at 8, then what we are doing is we are simply saying that now if you want to compute the sum of this window, you have to simply say that whatever the previous sum was there, which was 8, you have to add this current element into it, that is ARR I, and you have to subtract ARR I minus K. So you have to subtract ARR I, which is 0, 1, 2, 3. And 3 minus 3 will be equals to 0. So you are basically subtracting ARR 0 from it. So this is what it is doing, right? It is subtracting ARR I minus K from it, which is minus 2. So now the new sum would be 8 plus 8, 16, and 16 minus 2 is 14. So the new sum is 14. So we are now comparing that is the sum of this particular window more than the previous sum, which is absolutely the case. We have to write here 14, right? And then you have to move to the next loop, and in the next iteration, and in the next iteration, the value of I is now moving to 9, right? The new value of I is 4, right? It is at fourth index. And now again, we are saying that the sum is equals to the previous sum, which is 14. And you have to add this new element, that is ARRI, which is 9. And you have to subtract the value ARRI, which is 4 minus 3, which is ARR1. Right? And ARR1 means 5. So you are adding 9 and you are subtracting 5. And the final answer will come out as 18, right? So 18 is a bigger value, so we'll update the max to 18. In the similar way, we have to stop when I is less, when I will be equals to ARR dot length. But right now, I is not equals to array dot length. It is basically smaller, right? So again, one more iteration will takes place in which we are doing this particular task, which is 18 minus 1 and plus 5, which will be 22. So we'll update this 22 as well, and this is where our number of iterations will also stop. So this is how we are doing this particular task. Does it make sense now, Ketan? I hope that this makes sense, right? And now we have to cover some problems as well. So we're going to start from this lead code question number 643, right? So let's just start with that. Question number 643. So 643. And in this particular question, what it is saying is that suppose, all right, so it is saying, you people can read it first and then we'll continue. So just take 2 minutes, just look at this question, and I'll ask you a very simple question afterwards, but just take a look at it.
Ma'am, this question is similar to the question that we have done. The only thing is that we
Absolutely.
need to divide by k.
Absolutely.
Yes.
So there's one simple thing that you have to keep in mind here, right? That I'm going to ask you as well, that it is written over here, that is any answer. So the question is that you are given an integer array nums consisting of n elements. So obviously one n size array is there and an integer k is there. And what you are asked is that find a contiguous subarray, right? Which is basically our subarray only, whose length is equals to k. So now this sliding window concept has come because they are asking for a subarray of length k. So wherever you'll see this kind of thing, right? Because later on the questions are going to change as well. So wherever you'll see this kind of things, that is, uh, some question is asking you for some subarray with some k size window. So obviously, in most of the cases, it is going to make some sliding window concept will come into picture, right? So these are the like small terms that you have to keep in mind that will help you. Then you'll further go on solving some mixed type of problems. You'll understand that okay, these kind of token terms are coming, so it means that it belongs to this particular category. Right, so that all right, that has the maximum average value and return this value. So basically, it is asking for a subarray with maximum average rather than sum. It is going to ask us. It is asking us for the sum, asking us for the averages, not sum. Right, the change here or the line here written is any answer with a calculation error less than 10 raised to the power minus 5 will be accepted. Now, what it means is that when you will do the averages, obviously the answer is going to come in some point value, right? Some floating point value will come as our answer. So you have to understand one concept of your any programming language that you're using. It is basically a concept of your processor, uh, processor and memory rather than the concept of programming language, which is that whenever you'll try to do the sum of 0.1 plus 0.2, suppose, right? And I'll run it, so you'll get the answer as 0.3 plus 0.0004, right? But you know that in our, normal mathematics, what we have learned is that 0.1 plus 0.2 is equals to 0.3. It is not equals to 0.300004. So because of this reason, because of this answer, that particular line is written. Now the question is that why does that happen? Right? Why does it happen? So the reason is that computer doesn't store 0.1 as it is. It stores some values in the form of zero, not some values, but all the values in the form of zeros and ones, right? So even if you're storing some point values, they're going to be stored in this format only, 0, 1, 0, 1, right? So in fractional values, whenever you people use fractional values, you know that there are certain fractions which are not completely divided, or which are basically recurring in nature, right? So for those recurring nature kind of uh, fractions, these zero ones are basically going to repeat themselves, right, after some number, and they are not going to give you an exact value. So this is the first place from where this basically some error value or some calculation error can arise. The other part is when you will try to store 0.2. So 0.2, whenever you try to store a point value, how it is calculated and how it is stored is it basically is divided by some 2 raised to the power value. And when you'll do that, you'll notice that this recurrence will start to happen in this storage of the 0.2 as well. And just because of this reason, because of this recurrence which is happening over here, uh, because of that, a standard value cannot come out in the form of zeros and ones. So there are lots of number of this kind. And because of that, this error value will come, and that's why it is written. So do you people understand that why is this happening? Because we store these value in 0, 1 format, and there are certain numbers which cannot be stored in their exact fractions, because of which some error will definitely arise, and that's why this particular line is written over here. So it is not going to basically hamper our algorithm eventually. So ऐसा नहीं है कि you're going to write some different algorithm, right? You're going to write the same algorithm which you are using in the previous question. I'm just explaining this so that this line should be very much clear that why are they saying this. So they're saying this just because of this reason, that you will be computing 0.1 plus 0.2, you will be expecting the answer to be 0.3, but the answer is coming out to be 0.30004. Right now, this is a very small thing that is happening over here, but with larger numbers, some bigger bigger difference can come. So that's why they're allowing you that you can have uh, error difference. It is completely fine if it is in the range of 10 raised to the power minus 5. And eventually we're going to use some double value, so that's okay, right? So because the final resultant value you have to return in double, that's why. So this is basically the meaning of this particular line. Does it make sense? I hope that this makes sense, right? So now I think that this question you people can solve. This is completely similar. And if at all there will be any kind of problem, we are going to solve it tomorrow. But before that, you people can try this. So this is your problem number 643, which you people have to come tomorrow with, right? We can go for next question now. Right? This is a very simple question because, right? Can we move forward? If there will be any problem in this question, you can ask me tomorrow, we'll do it. But I think that this will be very easy. This like take only 5 to 6 minutes to solve, right? So that's why we should move forward and we should see to the next problem now. Yes, okay. So let's see another problem as well. So again, a very simple question, that is K radius subarray averages. But I'll explain it, of course. So 2090, let us see this question. This question you people can solve, but I'll just explain it very quickly. So this is your question 2090. So very simple and interesting question. I think this is of medium range, but the reason why it is medium range question is just because of the description, problem description part. Because of the problem description, they have made it a medium level question, but it is quite easy, right? So you people can read it out first of all. Take 2 minutes. This is 2090, and then we'll start solving this one as well. So it is also a very simple question. Just read it out once. Shall we continue, guys?
Yes, ma'am.
So what this question is saying is that you are given a zero indexed array nums of n integers and an integer k, right? All right. So basically in Java or C++, you are going to have a zero indexed array only. So it is basically saying that your nums array starts from zero index. All right. So, and an integer k is also given. All right. So k radius average. So what is this term here referring to, right? So first of all, let's understand what is this k radius average, right? So k radius average is basically that if suppose some array is there with you, right? So let us consider that there is one array with us. So 1 is there, then 2 is there, then 8, 6, 4, 3, 5. So suppose these all elements are there. So it is saying that suppose k value is equals to 3, right? So it is saying that k equals to 3 means that you have to compute this k radius average. So what is k radius average is? So we have to compute k radius average. So this term we have to understand. So just like how in circle, what happens is that there is a center point, right? And from this center, there is a left side radius of r size and there is a right side radius of r size, right? If you'll talk about diameter. In the similar way, it is saying that if suppose you want to calculate this k radius average, then it needs to be some element. So suppose you are saying that I is right now pointing to 6, right? So it needs to be that element which is having three elements to its left and three elements to its right, right? If suppose there are four more elements here, 1, 4, 6, 9. So now if I is pointing to 6, so now we'll ask this I that is there a k radius average possible for you? So your answer would be absolutely yes, because k radius average simply is saying that you, even though the value of k is 3, you have to look for a window of size 3 into 2, that is left and right, and plus 1 wherever your I is there. So you have to look for a window of size 7. So it is basically the same question. The only thing that you have to compute here is this 7. That is, you have to calculate that what will be the size of that k radius window, right? So the size of this k radius window is 7. So instead of going for 3, you have to this time calculate the sum or the average of 7 size window, right? Because for 6, you will have 3 elements to the left and 3 elements to the right. So that's why the size of window has increased. Now you can compute the average of this window. So suppose you are calculating the sum initially. So suppose the sum is coming out as some x value for this particular window. So now if you want to basically calculate the average, it will be simply x divided by 7, right? Then you can simply move this window ahead. So now 1 will be included and 1 will be subtracted. So again, for the next k average window also, k radius window also, the sum will be x because the same element is added and same element is subtracted. So the next average will be x upon 7. In the division, you'll always have 7. Right? Again, you're moving this window ahead. So you are including 4 and you are excluding 2. So x minus 2 and plus 4 divided by 7. This is the next average. Then again, you are moving this window forward. And this time you are, I think, excluding 8, right, and including 6. So whatever this y value has come, so y minus this 8 and plus 6 divided by 7. So this is your new window sum. And the last window would be whatever z value has come. So you have to include 9 into it and you have to exclude 6 from it. So this is your last window sum. So this is how you're calculating the averages, right? You have to divide it every time with 7 because you have computed the k radius size as 7, right? And now the
Ma'am,
question, yes,
ma'am, how did you get that formula?
because it was written in the question. See, now let us read the question and you'll get the point. So the k radius average of a subarray. So what is it? Let's read it out. So k radius average for a subarray of nums centered at some index I with the radius k is average of all the elements nums between the indices I minus k and I plus 1. So it is saying inclusive. So it is saying that if you want to calculate k radius average, you have to include all the elements starting from I minus k position, which is 3 elements to the left, and you have to go up till I plus k position, which is ith element is there and then I plus 3. So that's how you are basically taking 3 elements from the left, 3 elements from the right, and ith element you also have to include. So that's why that plus 1 is coming. So that's how total number are going to be 7 all the time. So the value of k is 3. Does it make sense that how we are computing that particular window size?
Yes, ma'am.
Right. So if there are less than k elements, so now this is also possible that if your I is pointing to 0, right? If you consider this particular case when you have because you're not going to start from 6 all the time, now you are going to start from 0. So if suppose I is pointing to 0th index, so there are 3 elements in the left are required, but there are no element in the left. So at this particular point, it is saying that uh, this window is not a correct window. So you have to put minus 1 in its place. So now you have to, in the final answers, you have to put some values. If you'll see here the answers, so you'll see it like this, that for 7, the answer is coming out as minus 1 because the window was not possible. Right. For 4 also, the window was not possible because left-hand side doesn't contain 3 elements. So that's why minus 1 is coming here as well. Then if we'll go for 3, again 3 elements are required in the left side which are not there. So that's why minus 1 is the final answer. Because window of 7 size is not possible, centered at 3. Right. But with 9, like starting from 9, the window of size 7 is possible. So that's why the answer is coming out as 5. Then you'll move this window ahead, the answer will come out as 4. Then again you'll move this window ahead, the answer will come out as 4. But as soon as you'll reach to this 5, so there are 3 elements in the left hand side, but 3 elements are not there in the right hand side. That's why the answer is minus 1. So does it make sense that why minus 1 are written in some of the places?
Yes, ma'am.
Because k radius is not possible in those places. Right? So this is also a simple question of a static window only. The only thing that you have to keep in mind here is that you have to think of your window by yourself. Yes, if k is less than 3, then also you have to put minus 1. And also, if you are reaching towards the end, right? So that you have to think of that how do we want to fill these places. It is very simple thing, right? My suggestion would be to fill the array initially with minus 1. So what you can do is, like, if you want to make this question even easy, right? If you want to make it more easy, then what you can do is that suppose if this is your array, right? 1, 8, 6, 4, 3, 9, 2, 8. Suppose this is your array and the value of k is equals to 3. So you people know that we need a window of size 7 because 3 into 2 plus 1, that is the formula to get the window. So 7 size window, if you will start from here, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So this is basically your first window. Let's have one more element in this right hand side. So this is our first window. Now you people know that if this is our first window, then it will be centered at kth position, right? Because at k equals to 3 only, you're going to get your first center, right? So you're starting from this k, and now you can simply at whatever k position is there. So you can initially fill all these value with -1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm just telling you about a simple approach that you can follow. Otherwise, it is completely up to you, whatever approach you want to follow, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So what my suggestion would be to fill all of these places with -1 initially, right? So we have filled these all the places with -1. And then starting from 3. So k is basically pointing to 3. So you can fill here the initial whatever average is there. So you can calculate the average, you can calculate the sum. Sum is equals to x, and then you can fill here x divided by 7. So whatever value is, you can fill at this kth position. Afterward, you have to slide your window. So you can keep your I at this place. So you have to keep in mind I is different. I is basically the last element and K is basically the center point, right? K is right now pointing to the center point. Now you're including the next element, which is 8. So you have to include it in the sum, x plus 8. And you have to subtract the first value, which is -1. And whatever this sum is coming out, that you have to fill at k plus plus position. So here, whatever this y value is, y divided by 7 will come. And then you'll move this window even further. So this is the last window to be included. So whatever y sum has come out, so you will include 9 into it and you will exclude 8 from it, right? And whatever this z answer is, so z divided by 7, this is going to be the average. So this is how we don't have to fill -1 also, because we have initially filled all the -1 to their correct places. So this is a simple algorithm that you can go for. Simple. This is also doable, right?
Yes,
Yes,
ma'am.
ma'am.
Right. So let's go for another question as well. Because today is our first class, so we can, if you people want, then we can continue. Otherwise, we can start from tomorrow as well. If you people are like comfortable, then we can go even further. The questions are there. You people have to tell me about your comfort level, because today is our first day. If you wish, then we can stop right here. We can start practicing. And from tomorrow onwards, we can continue with 2 hour session as well. Daily, we will have our sessions at 8 only. You people don't need a reminder as well, because it is going to be 8 o'clock only daily.
Ma'am.
Yes. We'll start from tomorrow so that all other guys who wants to join.
Okay, ma'am.
Right, because there were some students जिनका वो login नहीं हो रहा था, so we'll wait for them as well. So other students will also join. Right, till then you can try these 2 simple questions. Right, these are simple, so these are not hectic as well. You'll enjoy. Right. Other than this, there is a session scheduled for Saturday for JavaScript. Right. So we want to make some projects as well, but before that, we need to have a good understanding of JavaScript, which is scheduled for Sunday. Right? So Sunday, 11 a.m. So it is going to be a like a marathon kind of a session in which we'll try to cover most of the topics in the single session itself. So if you people are interested, you can take part in that as well. It will be for 11 a.m. Sunday, right?
Okay,
Ma'am,
ma'am.
will it be started from the beginning or like?
It'll start from beginning, but it will not be. I would not say that it is going to be very line by line kind of a tutorial, right? But I'm going to explain all the major and all the important topics which are required. And I think that if you'll start from the very initial phase, you'll be able to catch up also because I'm going to make it very simple for you people.
Okay, ma'am.
You people are going to enjoy for sure. Right. All right, guys. So आज के लिए we'll wind up the session. Tomorrow at 8 p.m. we're going to join and slowly we will increase the pace again. Right. So don't worry about that. Right. And अगर आप लोग को
One
कोई
thing
भी
I have to say,
yes.
ma'am, like you have taken the class for graph session and I couldn't attend. Like my exam
Graph
was.
will because many of the students couldn't attend that one now. So I'm going to take that session again.
Okay, ma'am. Thank you, ma'am.
All right. Any other question, guys?
Hello.
Yes, please.
Yes, ma'am. Sheet business.
Sheet. Yes, I'll pass on.
Hello.
Sheet, I'll pass on. Done. All right, guys. Good night, everyone.
Thank you, ma'am. Good night, ma'am.
Good night.